In this question, Callie is looking to move to a new area and she likes living in a really fast-paced, high-density type of area. We want to figure out if she wants to move to Templeton or if she wants to move towards Townsville. Now, quick look at it. Templeton has about 13,500 people, and then Townsville has more people. It has 15,000. So you'd think that she would want to go to Townsville just because it's got more people in it. But let's figure out what the density is going to be. Now, the formula for density is density equals mass divided by volume. And when we're working with a population density type of problem, our mass, that could be the population. And then the volume is going to be the area or like the miles where people are living. So this would be, let's say, the square miles in this particular problem. Okay, so what's the density? Well, the population, for example, in Templeton is 13,532. So I'll write down 13,532. And we divide that by the square miles, which is 414. And we'll get an approximation for our density. And that's going to be about 33. And I'm rounding that to the nearest whole person. And that's going to be 33 people per square mile. Now we're going to do the same thing for Townsville. So to find the density, we're going to take the population, which is now 15,142, and we want to divide that by the square miles. So that's going to be divided by 565, and we'll get an approximation for our density, 27. So that's going to be about 27 people per square mile. So where do you think Callie would want to move? Well, if she's looking for more people in a concentrated area, that's going to end up being this one right here, and that came from Templeton, which actually had a smaller number of people overall, but there's just more people kind of not necessarily packed into square miles because it's only 33 people per square mile, but it's just going to be a more of a density, higher concentrated density. In this question, Frankie owns a fish tank and it's going to be 5 by 4 feet. Well, that's the base, and it's going to be 6 feet tall, but the water of the fish tank falls short by about a half a foot. So really the water dimensions, you could look at them as being 5 by 4 by about 5.5 feet. Now we want to figure out what the population density of the fish in the water is, and there's 38 fish, so let's figure out what the volume of this water is going to be first. So this fish tank we will assume is a rectangular prism, so the volume is going to be length times width times height. So if I plug in some numbers here, we could do 5 times 4, that would represent the base. And then the height is going to be just short of 6 feet. That was going to be 5.5. So let me put some parentheses around here to kind of organize this a little bit better. And if I multiply straight across right here, it's going to give us 110, and that's going to represent feet cubed for this big fish tank. Now here's going to be the here's the formula for population density. Density equals the population, so that's going to be the number of fish divided by the volume. Now normally the value, or the part down here in the denominator, is square miles or some sort of area, but because it's a fish tank and it's three-dimensional, we're going to use volume. So we do not know what the density is, but our population we do know, it's 38 fish. And then we know the volume, that's going to be 110 feet cubed. So 38 divided by 110, that's going to be approximately 0.35, and that's going to be fish per cubic foot. So that means there's going to be less than a half of a fish per every cubic foot. In this question, an artist is working with a big piece of clay, and we want to figure out what the density of that clay is. So the formula for density is D equals M divided by V, which is mass divided by volume. And I'm going to start plugging in information from the problem into this formula. So we do not know what density is. That's what we're finding. And our mass, though, is 900 grams. So I can plug something in for that. But our volume, we still don't know what that is. We're not given it. But we could figure that out based on our information. The piece of clay that we're using is a cylinder. So if we find the volume of the cylinder using that formula, which is base, well, the area of the base of the cylinder times height, we could figure out what that volume is. So V is going to equal the area of the base. In the shape of the base of a cylinder is a circle, right? That's going to be the bottom of our cylinder. And the formula for area for that is going to be pi times radius squared. So I'm going to square a radius right here. And our diameter of this base is 16, so if we divide that by 2, we get 8, so that's going to be the radius. So now this part right here is the area of the base of the circle of the cylinder, and we want to multiply that by the height, and the height is listed as 45 centimeters. That's given in our problem here. So I'm going to evaluate all this, and for pi I'm just going to use the approximation. That's going to be 3.14. And when I multiply all this together, I'm going to get about 9,043.2. And that's going to be in cubic centimeters, so centimeters cubed. So that's going to be the volume of our cylinder piece. So I could take that volume and plug it in over here. So then the density is going to be 900 divided by this volume over here, which was 9,043.2, and that's going to give me about 0. A lot of it rounds. It's going to be about 0.10, and that's the density. We could write that as grams per centimeter. It's the density right there. In this question, we're going to be working with small little cubes of cheese. We want to figure out what's the longest that each one of these edges of the cube of cheese can be. Now the maximum mass here is going to be 485 grams. It's not going to be bigger than that. So I'm going to use that along with this number right here, which is the density. Okay, I'll circle that to figure out what the volume is going to be. So I'll show you what I made here. I'm going to write down the formula for density, which is density equals mass divided by volume. And we're given the density, right? That's going to be 90.4956. That equals a maximum mass of 485. So based on this information right here, I could figure out what that volume has to be. So to solve for V, I'm going to multiply this right side by V, so that cancels it out of the denominator, and I got to multiply this left side by V as well. So the left side is going to look like this: 90.4956 times V equals 485. And now I could get V by itself by just dividing out this big old number here, 90.4956, and that gets multiplied over, divided out over on the right side as well. So that goes away, and I'm left with about 5.36, and that's going to be cubic centimeters, so centimeters cubed. Now it's like, okay, well, the cubes of cheese have to have a volume of that 5.36, right? So I use the volume of a cube right here that was given to me. Volume equals S cubed and S is going to be the length of all the sides. So I'm sorry, not the length of all the sides, but the length of one side. So if our volume is going to be 5.36, I could actually just solve for that cube. I'm sorry, solve for the S. So to get rid of this cubing, I could find the cube root of the left side and the right side. So on the right side here, we're just left with an S, and this is going to be about 1.75. That's when you find the cube root of 5.36, and this is going to be in centimeters. So the length of each side of this cube is going to be about 1.75 centimeters, and that's going to maximize the size of it. The grams are going to be 485, and then the density is going to be about 90.4956 grams per cubic centimeter.